Quadratic inequality with one variable. Good day everyone. Today I will discuss how to find the solution set of quadratic inequality with one variable. Here are the steps for you to follow in finding the solution set of the given inequality. Step 1. Find the values of x of the given inequality. Step 2. Plot the values of x in a number line. Step 3. Assign the first, second, and third intervals for testing the values of x. Step 4. Test the value of x in each interval and the points between the interval. Step 5. Write the solution set of quadratic inequality in interval form. Let us have an example. Find the solution set of quadratic inequality x squared minus 2x minus 3 is greater than 0. Step 1. Find the values of x of the given inequality. First, we will write again the given inequality x squared minus 2x minus 3 is greater than 0. Let us write the given inequality into its equation form. So, it becomes x squared minus 2x minus 3 is equal to 0. Factor the given equation. The factor of the given equation is x plus 1 multiplied by x minus 3, which is equal to 0. Apply the zero product property. We equate each factor to 0. Then, we have x plus 1, which is equal to 0. And the other factor, x minus 3 is equal to 0. Then, solve for the value of x in each factor. So, we have x is equal to positive 1 is equal to 0. Transposed positive 1 to the other side of the equation. Then, turns to negative 1. So, we have x is equal to negative 1. For the other factor, we have a negative 3 is equal to 0. Transposed negative 3 to the other side of the equation. Then, it turns into a positive 3. So, we have x is equal to positive 3. Therefore, the value of x is equal to negative 1 and positive 3. Step 2. Plot the values of x in a number line. We need to draw a number line. From the right side are the positive numbers and on the left side are the negative numbers. There you go. Then plot the negative 1 and positive 3. There it is. Step 3. Assign the first, second, and third intervals for testing the value. So, from negative 1 to negative infinity, it will serve as the first interval. From negative 1 to positive 3. This will serve as a second interval. And lastly from positive 3 to the positive infinity, these will as the third interval. Step 4. Test one value of x in each interval, and also the points between the intervals. From the first interval choose any number as a value of x. I chose negative 2 for the first interval. Let x be equal to negative 2. Get the given inequality, which is x squared minus 2x minus 3 greater than 0. Then, substitute the value of x which is negative 2. So, we have negative 2 squared minus 2, substitute the value of x which is negative 2, minus 3, is greater than 0. Next, let us simplify each term. So, we have negative 2 squares is equal to positive 4. Negative 2 times negative 2 is equal to positive 4. Minus 3 is greater than 0. Then, we have 4 plus 4 is equal to 8, minus 3 is greater than 0. 8 minus 3 is greater than 0. Then, we have 5 is greater than 0. Is 5 greater than 0? The answer is true. Therefore, on the number line, all the numbers from first interval are solutions to the given inequality. Since they are solutions to the given inequality, we shaded the number line less than negative 1 towards the negative infinity. There it is. Next, let us move to the second interval. We will use any number between negative 1 and positive 3. To make it easier to solve, I will choose 0 as a value of x. You try the other number if you want as long as the number is between negative 1 and positive 3. But, for now, I will use 0. So let x be equal to 0. We will repeat the process just as we did earlier. We substitute the value of x and then simplify until we reach the desired result. The result is negative 3. Is negative 3 is greater than 0? The answer is false. On the number line, the numbers between negative 1 and positive 3 are not a solution to the given inequality. Therefore, the region in the second interval is not shaded. Next, let us move now to the third interval. Choose any number to represent the value of x. I will choose 4. Remember, in choosing the number, it should be in the range of the third interval. So, 4 is in the range of third intervals. Let x be equal to 4. We will repeat the process until we achieve the result. The result is 5. Is 5 greater than 0? The answer is true. Therefore the third interval is a solution set of the given inequality. The region of the third interval will be shaded. We are already done with the intervals. Now let us also test the 2 points which are -1 and +3, if are also a solution to the given inequality. Let's start with -1. Let x be the -1. The process is still the same. We substitute the value of x, which is -1, until we get the result. The result is 0. Is 0 is greater than 0? The answer is false. Therefore, on the number line, the point -1 will not shade. Just like an empty circle or unshaded point, indicating that it is not a solution to the given inequality. Next, let us move to the second point, which is +3. Let x be the +3. The same process. Just like in the previous 4 solutions. We substitute the value of x until we reach a result. The result is 0. Is 0 is greater than 0? The answer is false. Therefore, on the number line, the point will not shade, just as we have done earlier, just like an empty circle or unshaded point, indicating that it is not a solution to the given inequality. Step 5. Write the solution set of quadratic inequality in interval form. The solution set of the given quadratic inequality is for all values x such that x is less than -1, or greater than 3. That is how you write the solution set of quadratic inequality x squared minus 2x minus 3 greater than 0.
For more videos on mathematics, please don't forget to subscribe.